Now you can do conversational image segmentation with Gemini 2.5. So what does this mean? So you can give an input image and you can give a prompt to do image segmentation in that image. Okay. So how is this done and what are the different types of conversational image segmentation queries which are available currently? So let's look into it. So the various kinds of conversational image segmentation queries are, one is object relationships. So Gemini can now identify objects based on their complex relationships to the objects around them. So for example, you can do relational understanding, the person holding the umbrella in an image, ordering, the third book from the left, comparative attributes, the most wilted flower in the bouquet. So this is about object relationship. An example is over here where it says give the segmentation for the person holding the frisbee, right? So this is relational understanding. So you can do based on object relationships, right? Then you can do queries based on conditional logic. For example, it could be like the food that is vegetarian, the people who are not sitting. For example, if you have this image, so here you can have the query give the segmentation masks for the people who are not sitting. So basically the people who are standing, so it gives that. So this is conditional logic based conversational queries for image segmentation. Then you have abstract concepts. So this could be something like where you don't have a simple fixed visual definition. So this could in concepts like damage, mess, or opportunity. Like for example, in this image, give the segmentation masks for the area that should be cleaned up. So you have this spill over here, so it segments that. So here it makes use of Gemini's world knowledge. Then you have in-image text. So basically this requires OCR abilities for the model, which is one of the strengths of Gemini 2.5. So when appearance alone is not enough to distinguish the precise category of an object, the user might refer to it through a written text label present in the image. For example, in this particular image, if you want to segment the mass for classic walnut, right? So then it will do this. If you give classic pistachio, it shows the pistachio baklava. So it is able to segment this. So give the segmentation masks for the pistachio baklava. So it finds out that classic pistachio is over here. It correlates this text, and then it is able to segment this region. Okay, segment the objects here. Then you have multilingual labels also. Gemini is not restricted to single language. It can handle labels in many different languages. For example, if you have French cuisine over here and you have some food, so output the labels in language, so it says French. So give the segmentation masks for the objects, right, which are present over here in French. That's the idea over here. So it is able to do it and then show it like this. So they have an impressive demo over here where we can try it out as well. So these are the 5 types of conversational queries which are supported for segmentation. So previous models matched pixel to nouns like objects, right? The real challenge is conversational image segmentation. So it is related to referring expression segmentation in literature, which demands a deeper understanding, parsing complex descriptive phrases. So rather than just identifying a car, what if we could identify the car that is farthest away? So this kind of visual understanding is now present in Gemini. So they have a Colab notebook over here. They also have a demo. So before going into this demo, I would just like to mention over here is that this video is actually demonetized, and if you would like to support me, you can buy me a coffee over here. Buy me a coffee, Ritesh, or you can buy at this particular link, coffee.com Ritesh Srinivasan. Your support is much valued. Now let's go to the demo. Here is a demo of spatial understanding from Google. So here you can try out your various these image segmentation tasks. You can also see the raw prompt as well. So what I've done is that I have uploaded this image of food over here, right? So you can see some rice, you can see some veggies, you can see paneer over here. And this is the prompt: detect items, label each one with the name. So the raw prompt looks like this: detect items with no more than 20 items. Output a JSON list where each entry contains the 2D bounding box in box 2D and name in label. So the model over here is Gemini 2.5 Flash with no thinking. Okay, so let me send this, right? Let's see what happens over here. So this is a conversational kind of segmentation. So it is actually done some segmentation over here. So let's go into this and see over here. So it has detected paneer correctly over here. It has detected rice over here. It has detected this region as mixed vegetable curry. So previously when I done the same thing, it actually detected this individual items over here, basically individual vegetables. So maybe let me try increasing the temperature or maybe decreasing the temperature and see if I can get a different result this time. So it's actually processing it again. Let's wait for the results. Okay, so if you see here now, right, it says mixed vegetable curry, it says rice, but it says vegetables like gourd, carrot, right? If you go over here, I think somewhere it even detected as gravy. You have what else was available over here? Green, I think green bean or something was available over here. Yeah, green bean, tomato. So it is actually doing a good segmentation over here. So let's try out segmentation mask on this particular image. So give the segmentation for all objects. Let's see how it does it. Let's wait for the results. Okay. So it says this is snake plant. Very well done. This is the cat, the mask for the cat, the plant one. Okay, it is devil's ivy. Then you have the window sill edge, you have the window glass sky background, right? So it has done a very good job over here. So you can also try out this demo for your use cases. There is also this particular Colab notebook where they explain how to do this, right? So you can try out this Colab notebook. You need to create a Google API key, and once you create it, you can actually try out, they have this system instructions for bounding box. So here is the system instruction, which is return bounding box as JSON array with labels, never return masks or code fencing, limit to 25 objects. If an object is present multiple times, name them according to their unique characteristics like color, size, position, unique characteristics, etc. These are some safety settings, and here they explain how you can load an image, right? And then you have these various images over here, cupcakes or something, and then you can have a simple prompt to find all items in the image. To prevent the model from repeating itself, it is recommended to use a temperature over 0, in this case 0.5. Limiting the number of items is also a way to prevent the model from looping and to speed up decoding of bounding boxes. So if I don't know what will happen if you have more number of items in the image, whether this will work well. So here they are saying 25 items over here to detect. So this is a way of detect. Prompt is detect the 2D bounding boxes of the cupcakes with label, right, as topping description, and then you basically run it. So that's how you get over here. So they have another example over here. Show me the positions of the socks with the face. Given a socks image, so it shows over here. So this is like a light blue sock with cat face on the left. Okay. So this is like a light blue and green with, what is the output over here, with cat face on the right. Okay, so this particular this thing, so it is able to do things like this. Again, an example of that multilinguality. So this is a Japanese bento image over here, right? And here it detect the food label and label them with Japanese characters plus English. So that is what is done over here. So this is matcha Swiss roll. Okay, so you have Japanese plus English, this thing, multilingual labels over here. There is also Gemini reasoning capabilities. Draw a square around the fox shadow in this particular image. So you have this fox shadow. There is a square around it. So you can try out this particular Colab notebook. And here are some of the use cases where you can leverage this particular conversational, what you call queries, right? For conversational image segmentation. So this is for unlocking creativity, interactive media editing. For example, you have this particular image and you want to remove the shadows of the building, right? You want to create a mask around it. So instead of using complex selection tools, a designer can now direct software with words. This allows a more fluid and intuitive process, like for example, asking to select the shadow of the building and then you can edit it out. So you can do image editing by just talking to a model. That's what they're saying over here. So you can create tools like Photoshop with conversational capabilities. Now they are already there, but this model should be helpful in that. This is an example of building a safer world, intelligent safety and compliance monitoring. So if you look at this particular image, there are two people over here without the hard hat, which is mandatory in construction sites. So you can give this image and you can ask, Gemini to detect it. Now, other way of looking at it is you can have a camera placed and the camera can continuously look at this generate video, right? You can look at the frames of the video and you can automatically detect, and you can have a warning system which wants people to wear hard hats, right? So you can look at compliance and safety monitoring. You can replace this for traffic also, where you can have a continuous feed of vehicles, and you can then ask questions like who is wearing a helmet, who's not wearing a helmet. So many such applications can come out. The next example which they have given is the future of claims, nuanced insurance damage assessment. So damage is an abstract concept with many visual forms. For example, an insurance adjuster can now use prompts like segment homes with weather damage in these kind of images, and it should be able to do it. You can also maybe look at how much damage, 50% damage, 100% damage, whether that kind of a thing is possible or not, I don't know, but this is another use case. So these are some of the use cases. So you can think of a lot of different other use cases also. So you can now go and try it out on Google AI Studio or with the API. So they've given examples, this Colab notebook. This is their Google AI Studio demo. So you can try out and see whether you can make use of conversational image segmentation for your use cases. Hope this video is useful. I'll be putting all the relevant links in the description of the video. See you in another video.